Hi guys, I apologize for the confusion today with the technology. Yeah, everything's a little crazy right now with technology, so we got to do our best. So if you didn't join in on the Google Meet session today, you missed out just on some good chatting, but you also miss out on the conversation that I am realizing that not everyone has calculators, that when you go to second second vars to get to your distributions, this right here, this combo gets to your distribution list. The number 3 button for everyone, the inverse norm, doesn't look the same on all the calculators. And what the inverse norm button, if you're watching those videos from before, what the inverse norm button does is it tells you in a normal curve how many standard deviations you are away from your mean with a certain confidence interval. So I'm going to make a list here. I did this in the Google Meet, but for those of you who weren't there and for those of you who need a refresher, I'm going to make the distribution, and you need to jot these down because these are going to be used in your problem set, and also just for next week work, you're going to need these z-scores if you don't have the ability to do so. So we're going to do 4 different confidence intervals. We're going to do a 90% confidence interval. We're going to do a 95% confidence interval. We're going to do a 98% confidence interval. And we're going to do a 99% confidence interval. And one thing I want to remind you, the bigger the confidence, the bigger is the span. So the wider our range is. So the less confident we are really is going to be, more inside here. So it's going to be less of a z-score, because your z-score is how many groups of standard deviations you are away from this p-value that we have. So I'm going to push the buttons on my calculator. So if you have a calculator that you believe is doing this, I would go ahead and do it with me and see if you get the same thing. So I'm pushing second vars, which is my distribution list. I'm going down to button 3, which says inverse norm. And I'm going to put 0.90 with my area. I'm a 90% confidence level. Now, if you have a row that says tail, left, center, and right, you want this to be in the center. If you do not have that button, then those are the calculators that don't have this functionality, and you need to write this information down. So a 90% confidence interval is going to keep us, we're going to go 1.64 is what we're going to call it, 1.64 standard deviations away from the mean. A 95% confidence interval, this is going to be a higher z-score because I'm going to be more likely to gather my real mean in this, my real answer, my real proportion. I did second distribute again. I'm arrowing down to number 3, which is the inverse norm. I'm going to type in 0.95 with my area. Again, if you don't have this tail functionality on your calculator, that's fine. Just write these down. Now, in our notes earlier, I told you that we were treating this as 2 standard deviations away because we had this 68%, 95%, 99.7 curve we worked with all year. Now, this answer tells me 1.96, which is really darn close to that 2 that we've been working with all year. If you did a z-score of 2 or you did a z-score of 1.96, I would accept either one of those. Just make sure you show me that your work. So in your problem set, you have to do a 98% confidence interval. So I'm going to do second distribute. I'm going to go down to inverse norm. I'm going to go 0.98. I'm going to arrow down and take this down to paste. I'm getting farther away yet even because I'm more confident. I'm going to grab my real mean. So this is 2.33 standard deviations away from the mean. And 99% confident is going to give me this, even my bigger answer. You cannot be 100% confident you get the answer in there unless you go all the way from, 0 to 100. But going 2.58 standard deviations away from the mean would take you to your 99% confidence level. So what I need you to do is make sure that you have this down. If you need to pause your video and write these numbers down or know where to come back and find them, these are all important. So I'm going to work through problem 3 because of our technical difficulties today. It says that in a poll taken in March 2007, Gallup asked 1,006. The first thing I'm going to do is write down my N value. My N value is 1,006. That's how many people are in my sample. National adults, whether they were baseball fans, 36% said they were. A year previously, 37% of a similar size sample had reported being baseball fans. So we're going to use the 2007 numbers because it asked me for a 90% confidence interval in 2007. And in 2007, my proportion of the people that was 0.36. Sorry. Which means my proportion of people that weren't were 0.64. So we're going to go ahead and find our standard deviation. Standard deviation of this situation is the square root of 0.36 multiplied by 0.64 all over my 1,006. I'm going to type this in my calculator. If you need to pause the video, do, to make sure that you get the same answers that I do. When I type that in, I get my standard deviation is 0.015. Now it's asking me for the margin of error, which means how far am I off? And if you go back to your previous notes, we talked about the fact that the margin of error is how far I'm going to go to the right of my mean and how far I'm going to go to the left of my mean. So in a 90% confidence interval, remember, we're looking for a z-score of 1.64. So I'm going to do 1.64 multiplied by that standard deviation, which you could type it in like this, but honestly, I've hopefully encouraged you to never use a rounded answer to come up with your next answer. So I would just use that answer in my calculator, and I would type in 1.64 multiplied by my previous answer, which I still have programmed in my calculator, and my margin of error is 0.025. Meaning you're going to go 2.5% to the right or 2.5% to the left, and you are 90% confident that you're actually going to grab the real mean in this case. The real mean of the entire population, which we only are using a sample of 1,006. Explain what the margin of error means. So that's exactly what I just said on accident there ahead of the time. So what the margin of error means is the fact that, and I'm going to come ahead and calculate my answers. I knew I was starting at 0.36. I'm going to add or subtract my margin of error. So the numbers that I come up with here are 0.36 plus 0.025. So if I was here, I'm going to be at 38.5%. And I'm going to go on the other end too, 0.36 minus 0.025, which is, I'm going to go down here below it. I'm running out of space, 33.5. If I wanted to tell you that I am 90% confident that the real mean of the entire population of people who are baseball fans is somewhere between 33.5% and 38.5%, I am 90% confident that is the real proportion of the population that would call themselves baseball fans. Now, if I wanted to be 99% confident that I got the real answer inside there, my margin of error would be, let's see, larger or smaller? So you need to think in your head. If you want to be more confident, are you going to widen your range or lower your range? And obviously, you're going to widen your range because you want to be really confident that you grabbed the same the real answer inside that range of numbers. Remember that your 99% confidence interval, your z-score was 2.58. You would take that 2.58 and multiply it by your standard deviation. The question there was, would the margin of error be larger or smaller? And the answer would be larger. And we want to find that margin of error. So we're going to take I'm going to scroll back again. 2.58 is the z-score. So I'm going to take that 2.58 and I'm going to multiply it by my standard deviation again, which you could always calculate it again, or you could go up and grab that answer out of your calculating screen. So I'm going to type in 2.58 multiplied by the standard deviation, which gives me 0.039. So my margin of error, how much I could be off in this case, is about 3.9%. So the answer to this is 3.9% is my margin of error. If I was asked for my confidence interval here, like I found up in the beginning, I would take I don't need to go through this calculation because it wasn't actually asked to do it, but I'm just showing you what I mean. I'm going to take this and add or subtract in my 0.039. It's going to give you 39.9% on the high end, and on the low end, you're going to subtract almost 4, so 32.1%. I'm 99% confident that my baseball fans are between 32.1% and 39.9% of the population. So in letter E, it says, in general, if all other aspects of the situation remain the same, will smaller margins of error produce greater or less confidence interval? Remember, smaller margins of error make you less confident that you're going to grab the actual answer. So if you lessen your range of numbers, if your range of numbers was here, and you lessen your margin of error, how far you can be off, you are less confident you're going to get your real mean inside those two values. And then the question was, do you think that there's been a change from 2006 to 2007 in the real proportion of national adults who are baseball fans? So you're asking, like, basically, is there a difference between 36 and 37%? Is there enough difference there to make a change? I want you to think for a second on your own. Do you believe there is enough difference there? And I would say the answer is no. Now, if I go back to this slide, either one of these, my 90% confident and my 99% confident, I caught that 37% in here. Look, I caught that in there. That 37% was caught inside my 90% confidence interval and caught inside my 99% confidence interval. So no, I would say the answer to that question, do you think there's been a change from 2006 to 2007? And I would say no, I would not. There is not a change because 0.37 lies in our interval. I hope that helps. I hope you got this last piece of information here, which is our confidence interval z-scores. And if not, shoot me a message. Hope you guys are doing well. I know this is all crazy, but stay at it.